Okay, today we will discuss an important class of signals which is called as LTI systems, linear time invariant systems, and we will see how to find the response of such a system to any input. Okay, we will describe first in the discrete domain because it is more easy to analyze discrete time convolution. Okay. Convolution, it basically defines the response of an LTI system due to any input. Okay, so if you take a system which is linear and time invariant, it means it has both the properties. It has the linearity property, it has the time invariant property also. The system is linear, it means individual inputs, a linear combination of different inputs that generates or it gives a output which is the combination of their individual outputs. And secondly, this is time invariant. It means the output or the delayed output of the system is same as the output due to the delayed input. Okay, so this system follows these two properties. That means a1 x1t plus a2 x2t, its output is nothing but a1 y1t plus a2 y2t, which is called as superposition. And the second, since it is time invariant also, it means y of t minus t naught is nothing but equal to transformation of xt minus t naught. Okay, so the delayed output and the output due to delayed input, they are same. If it is continuous time, it is t. If it is discrete time, it will be n. Simply t is replaced with n. Okay, now how to find the response of such a system? So you have an input sequence xn, you apply this to a system which we assume now that this is a linear time invariant system. So how to compute the output of the system? So this output is basically computed using convolution. Okay, now for this what we do, we take the help of unit impulse signal again here, delta n. Okay, delta n signal has a property that if you multiply x of n with the delta n, you will get only the sample at n is equal to 0. It means it is basically nothing but is equal to x of 0 into delta n. Okay, or you can say that if it is shifting, if you use the shifting property, x of n into delta n minus n naught, it will be x of n naught into delta n minus n naught. Okay, so you take any input signal xn, what we do, we first express this input as a combination of unit impulses only. And how you do that? Suppose you have a signal xn like this. At 0, its value is suppose maybe 3. At n is equal to 1, it is 2. At n is equal to 2, it is 4. It is 2, and so on, whatever may be the values. Okay, I can express this signal as a linear combination of different samples. Suppose I take only one sample at n is equal to 0, which has a sample value 3. Then I take another sample at n is equal to 1, which has a sample value of 2. Another sample at n is equal to 2, this sample value of 4, and so on. Okay, so this sample 3, which is the sample of the signal at 0, It can be written simply as x of 0 into delta n. This can be written as x1 into delta n minus 1, and this can be written as x of 2 delta n minus 2, and so on, because delta n is present only at n is equal to 0, and at n is equal to 0 it is 1. So you multiply with x0, you will get 3 only. Rest all samples will be zeros for this. Okay, it will just sample one value, and that is at n is equal to 0. Similarly, in this you are multiplying x1 with delta n minus 1. So delta n minus 1 is 1, and when n is equal to 1. So at n is equal to 1, delta n minus 1 is unity. So multiplied with x of n, you will fetch the next sample, that is 2 at n is equal to 1. And similarly, delta n minus 2 is an impulse signal at n is equal to 2 with the amplitude 1. If you multiply with x2, you will get this 4. Okay. So likewise, any sample value of this xn can be denoted in terms of unit impulses. So as a result, I can write x of n as x0 into delta n plus x1 delta n minus 1 plus x2 delta n minus 2, and so on. And if it is a signal in the left side, it will be x of minus 1 into delta n plus 1, and so on. Okay. So any signal which is discrete, it can be expressed using this equation as a linear combination of weighted unit impulses. Okay. Now this is the input to this system. Okay. So I have expressed first x of n as x of 0 into delta n plus x1 delta n minus 1, and so on. So I can write in the form of a summation x of k delta n minus k from minus 2 plus infinity. Okay, this will simply generate this series. So it will be 1k is 0, x0 into delta n, then x1 into delta n minus 1, and so on. Okay, now this is the input to the system, which is a LTI system. We have to find what is the output. Okay, now since we assume that the system is linear, first property, it means if the input is itself a linear combination of different signals, so the output is nothing but the linear combination of different outputs. So yn in this case will be equal to the output of the system due to x0 delta n plus output due to x1 delta n minus 1, and so on. So their individual outputs, output of this plus output of this plus output of this, they are added together to form the output of the system. Okay, now for this we define one thing that is called as impulse response. Okay, so impulse response means what is the output of the system when the input signal is a impulse signal. So if xn, if I give delta n as input, the output of the system is called as impulse response. Okay, we generally denote impulse response with h of n for discrete case, and continuous it will be h of t. It means if my input is, if xn is your delta n, your yn is nothing but hn. Okay, so impulse response simply means what is the output of the system when the input is a impulse signal, unit impulse signal. Okay, and we assume here that suppose for this system it has a impulse response h of n. Okay, so you can characterize this system in terms of its impulse response now. Okay, now this output will be, now what is output due to x0 delta n? X0 is a constant, and since it is a linear system, so it also obeys the scaling property. Okay, scaling property means the output due to a1 x1n is a1 y1n. Okay, if x1n produces y1n, then a1 x1n will simply produce a1 y1n. This is also the part of the linearity property, which is called as the scaling property. It means output of this will be equal to x0. This constant will remain as it is, multiplied with what is the response of delta n, and for delta n we have response that is h of n. Okay, then output due to this is x1, and what is the response due to delta n minus 1? Now we here we use another property, that is the time invariance. If the system is time invariant, it means if you delay the input by some time, the output is also delayed by the same time. So if delta n generates output as hn, what is the output due to delta n minus 1? It is nothing but h of n minus 1. Next will be your x2 h of n minus 2, similarly so on, and it will be x of minus 1 h of n plus 1 for negative samples. Okay, so this is the output of the system, and you can express this simply, this series again, in the form of equation like this, where you have summation of x of k h of n minus k, k from minus to plus infinity, and this is yn. Okay, this is called basically convolution. Okay, so convolution is nothing but the response of a LTI system in terms of its unit impulse response, that is h of n. So if you know the impulse response of any system, which is LTI, you can find the output of that system for any input using this convolution equation. Convolution sum we call it as. For continuous it will be convolution integral. Okay, so we have used in this case, if the system was not time invariant, if the system is time variant, then you cannot have this equation h of n minus k. Okay, in that case, which is linear but it is not time invariant, your output will be something like this. It will be x of k into hk of n. Okay, where hkn is the response of the system due to delta n minus k. If it is not time invariant, it means the delay in the input will generate different delay in the outputs. Okay, so in that case you cannot replace hkn with h of n minus k. But if it is time invariant system, then only you can have this equation. Okay, linear and time invariant, both properties must be valid, then the response of the system can be computed using a convolution summation. Okay, now we will discuss how to compute this convolution using this equation. So you have an equation now, y of n is equal to summation of x of k h of n minus k. This is nothing but the response of LTI system in terms of its impulse response, that is hn, which we have called as convolution. So how to find this output now? Suppose if you find y0, the response or the output of the system at n is equal to 0, you will get simply x of k into h of minus k, n is 0, summation over k. Okay, if you find the response at n is equal to 1, you will get summation of x of k into h of 1 minus k for entire k. If you find at y is equal to n is equal to minus 1, it will be summation of x of k h of minus 1 minus k from minus to plus infinity. Okay, now if you interpret these equations, these three, what is this? You are multiplying h of k, x of k with h of minus k, and then you are adding all the samples together, and h of minus k is nothing but the folding of h of k. Okay, it means in order to find y0, what you have to do, you have to take x of n as it is, but you have to represent it in terms of k. Okay, suppose I take one example. You have two sequence, x of n is equal to 1 2 3, and let the impulse response of the system be 2 4. Okay, this is the impulse response. You have to find yn, the output of the system. Okay, so to find y0, what I do, I first represent the signal in terms of k. I write here xk, and the second sequence is here h of k. So xk is at 0 it is 1, then it is 2, then it is 3, and hk is at 0 its sample is 2, at 2 it is 4, sorry, at 1 it is 4, rest it is 0. Okay, now to find this y0, you can also simply find the series. It will be x of 0 into h of 0 plus x of 1 into h of minus 1 and so on. Similarly, plus x of minus 1 into h of 1 and so on. Okay, so x0 and h0 they are multiplied. So at x is equal to 0 it is 1, at h is equal to 0 it is 2. So 2 into 1 it is 2. Okay, then x1 it is 2, h of minus 1, so h at minus 1 is 0. It means everything after this is 0. Similarly, when you have x of minus 1 and h of 1, x of minus 1 is 0, but h of 1 is 4. So 4 into 0 you will get again zeros. It means you are getting only one non-zero value at n is equal to 0, that is x0 into h0. So this will be 2. Okay, otherwise you can also graphically what you can say, that you have xk, then you have plotted h of minus k. Now if you take h of minus k, this is the folded version, folding of h of k, that is h of minus k. When you fold it, it will become like this. At 0 it is 2, and at minus 1 it is 4, and then you are multiplying these two signals together. So when you multiply these two signals, you are getting the output sequence, which is x of k multiplied with h of minus k. So if you multiply these two, at 0 it is 2, at 0 it is 1, it is 2. So for n greater than 0, your h of minus k is 0, for k, sorry, and for k less than 0, your x of k is 0. So as a result, all other products will be 0. You are getting zeros in the product for other values of k, and then you have to finally add all them together. So when you add them together, you just get one non-zero, that is 2. Okay, so to find y0, what you have to simply do, you have to plot one signal as it is, you have to fold another signal, then you have to multiply them, then you have to add all the samples together, you will get y0. And similarly for y1, now what we are doing here is that You are multiplying x of k with h of 1 minus k. So this involves folding and shifting now. Okay. Now h of 1 minus k, since this is h of minus k, it is already folded. I have to generate h of 1 minus k. So what will be that? It means this h of minus k will be shifted by 1. Now where it will be shifted, to the left or right? Okay. See, I have already explained this when we have discussed these transformations. H of 1 minus k, I can write it as h of minus k plus 1 also. Okay. And how you can achieve h of minus k plus 1? Either what you do, you have h of k as input. If I first fold it, okay, it becomes h of minus k. And then I shift it. Now this shift can be to the left or to the right. If I shift it to the left, or if I shift it to the suppose first right, when you shift to the right, your k becomes k minus 1 or k minus 2, whatever is the shift. So it will become h of minus of k minus 1. This is first fold, then shift to the right. So it will become h of minus k plus 1. Okay. So if you are already using the folded signal and you have to generate 1 minus k, it means you have to shift it to the right by 1. It will become h of minus k plus 1. Otherwise, you can also achieve it like this. You start from h of k and you first shift it. If you first shift it, then in that case you have to shift to the left by 1. Then it will become h of k plus 1. Okay, k plus 1 means it is left shift. And then you fold it, it will become h of minus k plus 1. Okay, so either you can first left shift then fold it, or you can first fold then right shift. You will get h of 1 minus k. Now since we have already the folded signal here, it is, if you plot h of 1 minus k, it means you have to shift it by 1 to the right. So this signal is shifted by 1 to the right. So what you will get, your minus 1 sample will come at 0, that is 4, and at 0 it was 2, it will go to 1, that is, it will become 2. Okay, again then you have to multiply them. So you have plotted first h of 1 minus k, then you have to multiply with x of k, original signal. This signal will be fixed. This you have to first fold, multiply, add, you will get y0. To get y1, you have to first fold it, then shift by 1 to the right, again multiply. Now when you multiply these two signals, what will be the multiplied sequence? You will get x of k into h of 1 minus k. Now product of these two, this and this one. So at 0 it is 4, at 0 it is 1. So 4 into 1 it will become 4 at 0. Then at 1 it is 2, at 1 it is 2. So 2 into 2 it will become 4. Rest it will be 0 because there are no overlapping samples. And then you have to add all these samples together. So it is 4 plus 4, you will get 8. So y1 is your 8. Okay. Similarly, when it is y of minus 1, so what you have to do in that case? You have to get h of minus 1 minus k. It means this signal h of minus k will be shifted by 1 to the left. Then multiply with xk and then add all the samples together. You will get y of minus 1. Okay. So these are basically, every time you compute the output of this using the convolution, you have to use these 4 operations. So you have yn is equal to summation of x of k, h of n minus k. Okay. So what is the procedure to find this equation output of convolution is to first shift one signal, first fold, then you have to shift, then you have to multiply the two, and then you have to add them. Okay, fold, shift, multiply, add using this, and this has to be done for every sample, output sample. Of course, for n is equal to 0, you have to only fold and multiply and add. There is no shifting. But for n is equal to 1, n is equal to 2, n is equal to -1, you have to fold one signal, shift it, then multiply with the second, add them together, you will get the output. Okay, so if you are finding suppose y of 2, what you will do, xk you will keep fixed. Okay, hk you have to first fold it, then you have to shift by 2 to the right. The third is you have to multiply then xk with h of 2 minus k, and then you have to add all the samples of this product. You will get y2. If it is y of -2, in that case you have to shift by 2 to the left, then multiply and then add. Okay, so folding, shifting, multiplication and adding, these are the 4 operations which are used in the convolution summation. Okay, so I will take one more example. So what is the convolution of, suppose xn is equal to 1 2 4 6 and delta n minus 1 plus delta n plus 1. What will be the convolution of these two signals? Okay, or if it is simply, what is the convolution of x of n and delta n? What will be the convolution of xn and delta n? It will be nothing but xn. Okay, the convolution of any signal with the unit impulse will give the same signal, and this simply follows from the property of, or the definition of convolution itself. If you have the convolution of two signals, it means one signal is in input, one signal is the impulse response. So if I am finding the convolution of xn with delta n, so I can say my input is delta n and impulse response of the system is xn. So what is the output? So when the input is impulse, the output is nothing but the impulse response, which is equal to x of n. So yn simply becomes xn. Okay, and if you find the convolution of x of n with delta n minus 1, what will be the output? It will be nothing but x of n minus 1 using the time invariance property, because delta n generates the output which is xn, so delta n minus 1 will generate output which is x of n minus 1. So if you find the convolution of these two signals, what will be your output? It is nothing but x of n minus 1 plus x of n plus 1. This impulse, these two impulses will simply shift the impulse response of the system by 1 unit to the left and the right, and then you have to add them together. Okay, so if you plot xn, my xn is, this is 1, at n is equal to 1 it is 2, then it is at 3 it is 4, then at n is equal to 3 it is 6. This is x of n. So output is x of n minus 1 plus x of n plus 1. So if it is x of n minus 1, delay by 1 to the right, it will become at this point at n is equal to 1, then 2, 4 and 6. This is x of n minus 1. And if you plot x of n plus 1, this is shifted by 1 to the left, so at minus 1 it will become 1, then 2, then 4, then 6. Okay, and when you add these two together, you will get the output y of n. Okay, so y of n will be at -1 it will be 1, because at -1 this is 0, at 0 it is 2, it is at 0 this is 0, so at 0 your output will be 2, at 1 it is 4, it is 1, so 1 plus 4 it will become 5. Similarly at 2 it is 6, it is 4, so 6 plus 4 you will get 10, then at n is equal to 3, sorry, -1 it is 0, it is 1, at -1 it is 1, at 0 this is -1 0 1 2 3, this is 0 1 2 3 and 4. Okay, so it is 1 at -1, at 0 it is 2, it is 0, so 2 plus 0 0, then at 1 4 plus 1 5, then at 2 it is 6 plus 2 it is 8, sorry, at 2 it is 8, at 3 this is -1 now, 0 1 2 3, so at 3 it is 0, and at 3 it is 4, so it will become 4 at 3, and at 4 it is 6. This will be my output signal. Okay, otherwise you can also do it like we have done in the previous case. What you can do is that you can take it as x of k and say that one signal as xk, one signal as hk. Now delta n minus 1 and delta n plus 1, if you plot it, it is nothing but you have two impulses, one at n is equal to 1, one at n is equal to -1, or in terms of k I can take it as suppose hk. So at n is equal to k is equal to 1, it is 1, at k is equal to -1 it is 1, and at 0 it is 0, one sequence. The second sequence is your x of k. So at 0 it is 1, then 2, 4, then 6. Okay, then you can fold it, multiply with this, add, you will get y0. Fold, shift by 1 to the left or right, you will get y1 or y minus 1. Suppose if I fold it, I will get h of minus k, and in this case it is a symmetric function, your folded signal is same. Okay, and then I multiply these two and add them together. So when you multiply it, at -1 it is 1, at -1 it is 0, so 1 into 0 0, at 0 it is 0, at 0 it is 1, so it is again 0, at 1 it is 1, at 1 it is 2, so 2 into 1 2, you will get, so in this product you will getting just one non-zero value, that is 2, so at 0 it will become your 2. Okay, then you shift it by 1 to the right, it will become h of 1 minus k. So now at that time what will happen, at 0 it will become 1, at 1 it is 0, and at 2 it is again 1. Again if you multiply these two sequences, xk into h of 1 minus k, if you product it, you will get y of 1. Multiply and add. So at 0 it is 1, at 0 it is 1, so 1 into 1 1, plus at 1 it is 0, at 1 it is 2, then it is 0, then at 2 it is 1, at 2 it is 4, so 4 into 1 4, you will get 5, the next sample, and similarly the next sample and next. When you calculate y of -1, you have to shift this signal to the left by 1, h of -1 minus k, then again multiply and add, you will get the output. Okay, this is how you can find the convolution of the two signals. Okay, so you can see that one more important thing is that x of n has how many samples? 4 samples, and this signal which is h of n, I have taken it has 3 samples. One is at -1, then 1, and then 0. Okay, this has 3 samples. And in the output yn, how many samples you have? 1, 2, 3, 4, 5, 6. So the length of yn, which is the convolution, it is nothing but basically m plus n minus 1, where m is the length of xn, n is the length of hn. The length of the convolution will be m plus n minus 1. Okay. It means if one signal has 4 samples, another has 2 samples. How many samples will be in the output? It is 4 plus 2 minus 1. So it is 6 minus 1, that is 5 samples. Okay. And another thing that you can also conclude is that you can find the upper and the lower limit of the non-zero samples in the output. Your input starts from 0. This is at n is equal to 0. Then at n is equal to 1. This is at n is equal to 2. And this is at n is equal to 3. And your h of k, it starts from minus 1 to 1. Minus 1, then 0, then 1. This is the range. So when you find the range of the output signal, you have to simply add their lower limits and upper limits. So it is 0, this is minus 1. So 0 plus minus 1, minus 1. It means output will start from minus 1. This is 1, this is what here, minus 1. And it will go up to the sum of their upper limit. So it is goes to 3, it is 1. So 3 plus 1, 4. Okay. So this is how we can find the upper and the lower bound of the output sequence by just looking at the input signal and the impulse response. Okay. So you have a question for this, or before this, there is another alternate way to find the convolution. Suppose when you go for any competitive exam, if I take two sequences, x of n is equal to 1, 2, 4, 6, and h of n is equal to 1, 3, 1. You have to find the convolution of these two signals. This is a question for you for this lecture. I will give you the answer, but you have to do it in detail in using graphically. You have to first represent this as xk, then this is as hk, then you have to fold it, then you have to multiply, add, you will get y0. Then fold it, shift, multiply, add, you will get y1, y minus 1, y2, and so on. That you have to do. Okay. And what will be the answer for this that I will give to you? You can check with this. You have to first write x of n, that is 1, 2, 4, 6 in this row, and in this column wise you have to write h of n, this next three samples, 1, 3, 1, and you have to multiply this with this. Multiply this all the samples with individual samples of h. So it is 1 into 2 will get 2, then 4, then 6. Then 3 is multiplied with all the samples of x, so it will become 3, 3 into 2, 6, then 12, then 18, then again with 1. So 1, 2, 4, and 6. And then you have to add them diagonally. You will get yn as the output. So it will be 1, 3 plus 2, 5, 6 plus 4 plus 1, 11, 12 plus 6 plus 2, become 20, then 18 plus 4, 32, and then finally 6. Okay. And you can also take this one more change. You can take this as n is equal to 0 here. This arrow means that it is this sample is at n is equal to 0, so it will be at n is equal to minus 1. This is at n is equal to plus 1. Now what will be the limits for output? See, this signal has 4 samples, this has 3. So output has how many samples? 6. 3 plus 4 minus 1. Now what will be the VN will be n is equal to 0 in the output. So the lower limit for this is 0. It starts from n is equal to 0, 1, 2, then 3. This is n is equal to 3. And this starts from n is equal to minus 1. and it ends at n is equal to 1. It means your output will go from 0 plus minus 1. This will go from minus 1 to 3 plus 1, 4. This is at n is equal to 4. This is at n is equal to minus 1. So 0 will be here. So minus 1, 0, 1, 2, 3, and then 4. Okay. So you have to find the convolution of these two signals using the graphical method that I explained, and you have to check that the result of your answer should match with this. Okay.